Okay, so I got some water, our soil sample from the farm. This is a sample that I have at the college that we would use in the lab. Then I've got a graduated cylinder and a beaker. I think at home, you don't need a beaker and a graduated cylinder. A jam jar would work just fine. Something that's a bit tall. Um, that's for later. Let's start with the first thing, which would be what we just call the ribbon test. So you could do this without any specialized equipment in any soil sample you find around your house or wherever. Take a small amount of soil. Like I'm going to say that's about right. Something that's going to fit in your palm. And we want to wet it just a little bit. I'll see how that works. I'm going to try to work it. This is pretty heavy soil. There we go. So I'm going to pretend I'm playing with clay at school. Now, this happens to be a clay-like soil, but it could be a regular soil. You can almost say I got a little too much water in this. I can always add a pinch of some dry soil for those of you making your COVID-19 bread at home. Okay, so there's a couple ways you can do a ribbon test. There's the method that's described by Rainbird on this week's class, which talks about just getting a ball of soil, moistening it. How many times do you get to say moist in a day? Well, today lots. Then squish it and see if it holds the shape that you squished it into. Can you see ridges from your hand so it's holding its shape? When you touch it, does it easily crumble? None. This is a clay soil. I'll try to find a looser soil after this video and maybe do an addendum. So that's my farm soil. The other one is the ribbon test, where you really got to knead the soil to make sure there's no lumps for this to work. I kind of prefer the palm one, to be honest, but the course specifies ribbon test, so we're going to do it. By golly. So you can roll it into a cylinder, maybe a little less soil, okay? And then form a ribbon. Now, what is interesting that the ribbon test does is it shows the edges breaking up a little bit as I do this. So it's holding its shape fairly well, but it's not like it's a continuous shape. It is cracking. And at the end of the day, this is not 100% clay we're dealing with. This is the soil that's high in clay. So I would say that is a clay soil. It's probably more clay than ought to be, so I can't call it a loam, but this is going to be more than 20% clay. We won't know how much until we do the sedimentation test, but I'm going to do a video about that later. So let's stop, and I'll reset with the other soil. Going? We're back. Okay, so this is the sample from the college. A couple of years ago we had the soil all nicely sorted, but I think over the last couple of years students have been dumping the wrong soils back in the wrong bin, so I don't even know what's in this, but typically this would be silt and clay. So let's see what we've got. It's really dry because it's been in a lab for a few years, so we got to rehydrate this. Look at that. It's just powder. So let me get some more. All right. Throw a little bit of water in there. Who knows? Maybe it's sandy. Whoa. Okay, that's a bit much. Yeah. Okay. All right, now we're getting somewhere. This is interesting. This actually may be more of a sandy soil, which means I don't have to go find a crumbly one. Okay. So I did the same as the last time. I'm rolling it, I'm forming it, I'm squishing it, but it crumbles and it's holding its shape. I don't see the shape of my palm quite as clearly as I did before. So this is actually not really a clay soil. This is more of a silty, sandy soil. So let's try making a ribbon. Okay, so I'm going to take a smaller piece of this and roll it out. And then I'm going to try to form a ribbon. And look at that. It's not holding. It's not forming a ribbon. It's crumbling. So this is definitely a sandy soil. See, it's even having a hard time staying clumped. So this is see, look at that. See, I'm trying to squeeze off. Oop, there's a rock. It's not working. Whereas the old soil, I could form a ribbon. So right away, the high clay content soil holds a ribbon shape, forms a ball in my hand. When I squeeze it, I can see finger or my skin creases and stuff. It holds its shape. When I form a ribbon, it's fairly well shaped. With the sandy soil, it's constantly crumbling. So that's really interesting, right? So we have a sandy soil, we got a clay soil, just based on qualitative assessment. So we're going to come back and I'm going to mix some soils into the different beakers, and then we'll let them settle overnight, and then I'll do a video showing you what they look like after that. All right, so I'm going to show you how to do the one with the soil from the vineyard. The other one I can try in the beaker, but it's kind of clumsy. I would rather something a little narrower and taller, but we can do it. The nice thing about the graduated cylinder is that I can measure the height of different layers. So let me back up and explain what I want to do here. I'm going to add a small amount of soil to here, top it up with water, shake it till the soil is completely solubilized. All the parts are floating in a nice slurry. Shake it lots. Then we're going to set it down and we're going to let it settle. The bigger, larger structures will settle immediately, like pebbles and stuff. Then your next size particle will settle right on up until we get to the clay. Now, typically, large objects are instantaneous. Sand within 5 minutes is all settled. Silt will settle within about 2-3 hours, and the clay takes about almost 24 hours till basically you let it sit till the top layer of water is clear. Then you can look through the side and you can measure, okay, so if I have 10 centimeters from bottom to top, that's my total height. What percentage of each layer represents does each part component make in the soil, right? And if from the lesson, the lab lesson, you'll remember anything over 20% clay is considered a clay soil. Anything over 40% sand is a sandy soil, right? All that kind of stuff. So once you know what percentage, then you can take those percentages, plot them on your texture triangle, and then you can classify your soil as a sandy loam, a clay loam, a loam, or silty, based on what percentage you see. So I'll make the slurry, and then we'll let it settle, and we'll come back tomorrow. So I guess you can watch me play with dirt. Great, eh? I'm going to mix it in a beaker, and then I'm going to come back and pour the slurry using my fancy-dancy screwdriver. Trying to get the big chunks solubilized. Roots we don't really want, so do your best to tease plant matter out of the mix if you can. It's taking longer than I thought. Wow, this is exciting, eh? Online learning. You get to watch someone stirring muck with a screwdriver. Woo! All in the name of science. That's what you tell your parents when you got that jar in your kitchen. Just tell them, hey, my instructor in college told me I got to put this on the windowsill. Okay, I think we have completely solubilized our soil. It's good. Okay, all right, let's pour it in. Did you ever do this as a kid? You dare your friends, I dare you to drink it. And your mom's like, dinner time. Like, oh, thank goodness. Okay, I'm going to put 40 mils in. And that is it. Now we just got to let it sit for, 24 hours and then come back. And I'll do the same thing for this, but I only have one graduated cylinder. So we'll try the beaker. All right. See you in 24 hours. Okay, so it's actually been more than 24 hours. I've been waiting for quite a while for the soil to settle from the grapevines. As you'll see, there's the dark layer at the bottom, which is a sandy layer. I'm not sure. Yeah, you can kind of see how that looks like sand. And then the next layer would be our silt, and then we have clay. And obviously clay is the smallest particle, it takes the longest to settle, but I'm astonished at how much clay there is. I thought it wasn't settling, but if you look carefully at the top, you will see that there is a milky, clear layer. So I have a feeling this would settle even more. So what I wanted to do was sort of suck some of this off. And it's not particularly solid. I think it's starting to... Now we're getting into something that's a little more settled. But, oh man. Yeah. Looking at the syringe, it's still pretty fine. I think that's going to take... That would have taken quite a few days to settle. I hadn't anticipated on that. But it doesn't really matter, because what we're going to come to the conclusion here is that by looking at the scale down here, there's 1 centimeter, 2, 3, 4, 5, 6, 7.5 centimeters. Let's assume this is going to settle down to half its thickness. So we're looking at 60 centimeters. The base is actually up 10 centimeters. So we're looking at 50 centimeters or 50 millimeters total height. And rough guessing, the silt layer is less than 10 millimeters. And the clay and the sandy layer are about equal. But at the very least, what that means is that we have more than 20% clay, which obviously we have a clay soil. If you want, you can jot down the numbers or take a still photograph of the video and calculate the percentages. And then taking the percentage of, say, the clay and the sand alone, you could calibrate where this is in the texture triangle. Remember, you don't need all three, because it only takes 2 points to triangulate. So I'm going to say it's 40% clay, 40% sand, and 20% silt. So we're looking at a real clay soil, which is, in fact, what it is. Let me swap out that cylinder, and let's look at the sample from the college, which settled fairly quickly. And interestingly enough, I'll let you take a close look. Very difficult to see, but there is, it's very hard for you to see. It's sand at the base. You can kind of see the characteristic coarse. No, that lighting won't help. I gotta say, people who make YouTube videos have probably spent a lot of time on lighting, and I never would have thought that. My camera insists on focusing on this jar back here, which is rather amusing. Let's just move the jar. Haha. Now what are you going to focus on, huh? Okay, so it's not really showing up, and it's very subtle. So what I'm going to show you with my little tube here is that it's sand up to about here, and then silt. There's no clay. This settled very quickly, which tells me it's not clay. So we got sand and we've got silt. So it's about 60% sand, 40% silt, and zero clay. Okay, so that's going to be a silty, sandy soil, obviously. But plot it on the textural triangle, see what you find. Anyways, those are fairly simple tests you can do at home with any kind of tall jar or glass, with a soil sample from your yard or your neighbor's yard or even a customer's yard if they're trying to decide what type of soil they have and how they want to amend it, right? I had a student ask me once, oh, if your soil is very low in clay, should you add clay? Well, that's not normally done. The only time I've seen soil added to something was when a farmer had made a mistake and they were trying to absorb too much micronutrient that someone had added just to make sure there's no toxicities, because clay will suck that up. But generally speaking, if your soil is very loose and draining in a gardening or horticultural context, you're going to add organic matter, which is going to have similar properties to the clay in terms of water holding capacity and nutrient storage. But we're going to get into that more as we go through the course, so let's not get bogged down on that. This first lesson was all about particulates, like our classic picture as we see down here with this separation, the sand, silt, and clay, and how those three particles interact to basically dictate what type of texture the soil is going to have. So, all right. Well, I hope you found this interesting. I'm going to move on to my next lab for you guys. All right. Talk to you later.